Please welcome Itamar Yadid, Migal Research Center.
Hi all, and thank you for coming to this exciting event. I'm Itamar Yadid, a researcher at Migal Galili Research Institute and Tel Chai Academic College. I'm also a co-founder of Augmented Reality, a startup that produces protein-based functional ingredients for the food industry. Today, I am honored to introduce Projini Agchem that addresses the challenge of weed control and contributing to sustainable food productions for years to come. I have chosen to nominate Projini because I am truly impressed with their interdisciplinary approach, which combine chemistry, physiology, and protein science, which they leverage to develop innovative solutions that are both effective and environmental friendly. Moreover, I am confident that Projini Agchem is a company with a bright future. They are tackling one of the world's most pressing challenges, and they are doing it with ingenuity and creativity. I am proud to nominate them for this award, and I look forward to seeing what they accomplish in the near future. Thank you.
Breaking the wall of resistant weeds with AI-generated herbicides. Dotan Peleg. Projini Agchem.
Thank you, everybody. Food security, we tend to think about it as an issue of geography, but actually food insecurity is a matter of time. There is a timer, a countdown that we don't see. I'm not talking about this one, I'm talking about a much bigger one. If you speak with anybody from the crop protection industry, he will tell you that we are losing grounds in enabling to produce effectively enough foods to feed the world. If you look specifically on herbicides meant to control weeds, a farmer goes to the field, he either grows his crops or he grows weeds. When weeds become resistant to herbicide, we have a problem. And when the herbicides, the agents which are aiming to control the weeds, are removed from the market because of regulation, it's great for us as the public, but it's creating a problem for the farmers. Actually, 70% of the active ingredients have been removed from the market because of regulatory pressure. And the last new mode of action in this industry has been decades ago. So my question, the first question will be, what wall should we all be aiming if we want to secure our future? When we think about energy, we know we want replacements to nuclear power. When we think about crop protection and pesticides, we understand we don't want synthetic pesticides, so we want to replace them with biopesticides. They're clean, they came from the nature, so we like to put them back to protect the crops in the nature, and it's the same like using renewable energy, which is great. But there's only one problem. It doesn't solve our food insecurity countdown. Merely 10 or 20% of the crop protection market use biopesticides. If we will all convert to biopesticides, we can produce maybe 5% of what we need to consume to eat. So when we think about energy, we need a new school. We need forward thinking, like what we heard before about fusion. What's our new thinking about pesticides in crop protection? We certainly have a vision for that. It's computed chemistry. If we want to create new chemistry, the best way to do that is to predict them. This is the team of Projini. They're data scientists who have teamed up to challenge the current boundaries of computational science. And when they were able to overcome the current boundaries of computational chemistry, they were able to find more than 20 novel compounds in their discovery project, which at some point of time attracted the attention of Bayer Crop Protection, who have challenged the team to find a new herbicide. And it was a very challenging task, because the last mode of action, that means the last time where a new mode of action, a chemical applied to a plant, attacked it in a new biosynthetic pathway, was decades ago. And this is the first ever herbicide that we just found using our computational chemistry, It is the first ever in so many aspects. It is the first ever to control protein interaction as the mode of action. It is the first ever to control a new synthetic pathway, biosynthetic pathway in the weeds, which is not used commercially. It is the first one to apply small molecule to interfere with protein interaction. But the most important thing, it is the first one to present a higher return on investment in discovery of compounds. In the industry today, if you look at investment in new compounds, we are spending billions and receiving nearly zero. To get a new patent, we usually spend $50, sometimes $90 million. We were able to patent a new herbicide with less than $1 million, and we have additional in the pipeline. I'd also like to mention that not only replacing the current toxic herbicide and removing them through safe chemistry. By the way, this is what we're going to hear in 5 or 6 years from now if we don't solve the problem of crop protection, right? Sorry, not enough food for everybody. The emission of CO2 has been reduced by the introduction of herbicide and has been then lifted through the emergence of herbicide-resistant weeds. So if we are able now to fight and control resistant weeds, we can positively impact climate. And with this, I've ended my presentation. Thank you.
Wonderful. Thank you very much. Okay, so let's go for questions. Jury. Okay, you have to be faster because they are faster than you here, right? Okay, Frank. Then, yes, sorry, here. Hold on, sorry, can you go a little bit to the back? It's better for the camera, and it's also better for me to see you. Thank you. So, okay, 1, 2, and 3 first, and then we will take it for the rest. Thank you. Frank was first.
Computational chemistry, virtual screening, dogging, all this is not new. This is used in the pharma industry for the last 20 years. You need to have the structure of the target protein, especially if you target protein-protein interaction. How many potential drug targets in your industry are already solved, the structure solved and the structure known?
Okay, actually, if you look at computational chemistry, especially one that is looking for new bioactives, like in pharma, you would realize that if you not only go after enzymes, but onto protein interaction, your target space is maybe 2 or 3 or 4 times bigger in orders of magnitude. What's new about what Projini is doing is not just the fact that we were able to address protein interactions or find new bioactive sites or even challenge new crop protection inputs. We have actually looked differently at how computational chemistry is being done. Okay, you mentioned docking, virtual screening, target selection, all that is great. Still, most of the discovery projects fail. So what we looked at is a totally different representation of chemistry, which then allow us to increase the success rate of discovery project, including new targets, including protein interaction, including the first ever that we managed to find new active ingredients for crop protection.
Okay, thank you. We have a second question here, next to Frank. Thank you.
Thanks for the pitch. I wanted to ask if you show the evolution. So how you really differ with the new product with the bioherbicides? Like, what's the main differentiator?
The main differentiator is that we are addressing a totally new biosynthetic pathway in the weed. Okay, and we were able to find a new bioactive site and a new protein and find a new molecule that we're working at because we use computational chemistry. So the main evolution is in the discovery process, which leads then to a safer and more effective output.
Okay, thank you very much. We had a question here at the front also, I think. Can we have the microphone here, please? Thank you very much.
Could you speak a little bit to the dosage that's required for these small molecules to be effective and how often you have to spray?
Actually, this is the easiest question that you can compute. Okay, when you ask the computational chemistry to find a molecule that will be cost effective, this is probably the easiest way to compute. You can predetermine a certain dosage that will be effective in the field, that will be non-toxic, and you can compute that. there are actually additional many challenges that one needs to take into account when he's computing a new chemistry. But you're right that the bottom line that everything will be then measured on cost effectiveness. So yeah, cost effectiveness is probably one of the first things that we look on, and then additional issues like toxicity, safety, sustainability, the ability to be specific to a pest and not to harm other non-target organisms.
Thank you. Very short question here on the second row. Very short answer, please. We have only 20 seconds left. Be fast.
Exactly what you mentioned. I mean, inventing something that is a new bioactive is fine, but can you also do toxicology, water toxicity, teratogenicity of your new active ingredient? That would be great.
Please, a yes/no answer. Thank you.
Yes.
Okay, thank you. That's the end of the time. Thank you very much.